Hello students, welcome to my class. In this video we are going to be discussing about power related concept problems we are going to be discussing. So let us see the first question. A force of 2a cap plus 3j cap plus 4k cap Newton acts on a body for a 4 seconds is given, and it's going to be producing a displacement of 3a cap plus 4j cap plus 5k cap meter. The power is used, they are asking. Here a force is given as 2i cap plus 3j cap plus 4k cap Newton, and here is going to be producing the displacement is 3i cap plus 4j cap plus 5k cap, and here for time t equal to 4 seconds is given. So the power is used, they are asking. Power formula will be getting as the rate of doing work, or work done by time will be calling. Work done, again you can call it as F bar dot S bar by T you are taking. Here you can take the dot product of the two vectors. This is 2i cap plus 3j cap plus 4k cap dot here 3i cap plus 4j cap plus 5k cap you can take by here you can take as 4 seconds you can take. Then P equals to here you just do the dot products rule. So here we can take as I cap dot I cap will be 1, and I cap dot I cap and j cap dot j cap, k cap dot k cap, which will be equal to 1 you are taking, and here I cap dot j cap dot k cap dot I cap here, which will be equal to 0. So here when you are multiplying each with the I cap dot I cap will be here it's a 1 will be getting, so 2 3s are 6 will be getting plus, and 3 dot 4 will be getting as 12 will be getting, and here 4 and 5 here will be getting as 4 5s are 20 will be getting. Remaining all Cartesian coordinates I cap dot j cap I cap dot k cap, here it will be 0 will be getting by 4 you can take. So here we will be getting as together this value will be getting as 38 by 4 you can take, 2 19z 2 2z, here we will be getting as 9.5 watt is the answer. Let us see the next question. The next question says here the force required to move a body with a constant velocity which is directly proportional to the velocity is given. So here they have given us force which is going to be producing with the constant velocity which is directly proportional to the velocity is given. The ratio of the powers required to move the body with a velocity of 20 meter per second to 30 meter per second they are asking. Power they are asking here. Power, in terms of the force and velocity you can write it as, here this is an instantaneous power relation. This is F bar dot V bar you are taking. So here already force is directly proportional to velocity is given. So here you can take as with this. So here this is P is directly proportional to, here you can take as V square you can take. Then here you can take as here the ratio of the powers if they will ask means P1 by P2, which you can take as V1 square by V2 square you can take, which is nothing but here 20 whole square by here you can take as 30 whole square you can take, which is nothing but will be getting as 4 by 9 will be getting. So 4 by 9 is the correct answer. Let us take the next scenario. Next question. Two men with the weights in the ratio 5:3 is given. They run up in a staircase in times. So the times ratio is given as 11:9 is given. So the ratio of the power of the first to that of the second person they are asking. So here two men they are carrying the weights with the ratio of the 5:3 they are given. Means here the weights ratio is given as 5:3. So here it's given as 5:3 is given, and here they are moving in a time interval of T1 by T2 ratio is given as 11:9. So power they are asking here. So staircase they are moving in the sense here they are doing some work. So power equals here will take as work done by time. They are reaching certain height in the sense work done can be stored in the form of potential energy you can take mgh by T you can take. you can take here. So they are reaching the same height, you can take. Height will be a constant value. Here with this here you can take as P is directly proportional to weight by T, you can take. Their weight by T, you can take. So here you can take as, so here H you can make as constant here in this case, students. So the ratio of the powers will be getting as, this is W1 by W2 into here you can take as T2 by T1, which is nothing but weights ratio is given as 5:3, and here times ratio is given as 9:11 is given. So here it's a 9:11 it's given. So here you have to simplify this one. Here we'll be getting as, it's a 15 by, this is 3 3s and 5 3s are 15 by 11 you will be getting. Let us see the next question. The next question says the power applied to the particle varies with the time is given as P equal to 3t square minus 2t plus 1 is given. It is in watt, where t is in seconds. The change in its kinetic energy from t equal to 2 seconds to t equal to 4 seconds they are asking. Power is the function of time is given, students. Here P equal to 3t square minus 2t plus 1, and here the change in its kinetic energy they are asking. So power equals to, here you can take as dp. Suppose here it's a dp you are taking small change in the power dp, which will be equal to, here you can take as dw by dt you can take. It's nothing but work done when you are calculating. dw equals to, here you can take as integral, this is power, small power you can take, this is dw equals, here you can take as p into dt you can take. So p is given as here 3t square minus 2t plus 1 is given into dt you can take. So integral limits is given. Time is going to be varying from 2 to 4 seconds you can take. So here you are going to be calculating the total work done. So here you can take as integral dw you can take. Integral dw is nothing but w you are getting when you are doing the integration here. So here we will be getting as this is 3 into integral t square is nothing but t cube by 3 will be getting minus integral 2 in 2t dt, in the sense 2 into t square by 2 will be getting plus 1 into dt will be getting as t will be getting. So here you can take as between the limits 2 to 4 you can take. 3 gets cancelled, 2 gets cancelled. Now you have to substitute. They are asking kinetic energy according to the work energy theorem. Work done can be stored. Work done is nothing but change in kinetic energy you can take, which will be equal to, here t cube in the sense here 4 cube, that is 64 minus 4 4s are 16, plus we will be getting as 4 will be getting minus, and here upper limit minus lower limit you can take. This is 2, you have to substitute. 2 cube is nothing but 8 minus 4, 2 square 4, plus here we will be getting as 2 will be getting. So here it's nothing but here this is 68 minus here I will be getting as minus 16, that is 52 minus here minus 6 will be getting, which is nothing but here will be getting as 46 joules here getting. So here change in kinetic energy will be getting as 46 joules here getting. Let us take the next question. A car seller claims that his 1000 kg car can accelerate from rest to a speed of 24 meter per second in just 8 seconds is given. The engine of the car on an average should be off, they are asking. So here they are asking the power value, they are asking here. It's going to be moving, accelerating from the rest to a speed of 24 meter per second in just 8 seconds. So here you just look at, students, here power equals to, here you will be taken as the work done by time or the rate of doing work will be calling. So here work done can be stored in the form of the change in kinetic energy you can take, and here it's nothing but half mv square minus half mu square by t you can take. Initially it starts from the rest in the sense initial kinetic energy you can make as 0, which is nothing but here you can take as half mv square by t you can take. Now you have to simplify this one. The power which will be equal to half into mass in the sense here will take as 1000 kg into velocity will be getting as 24. So here you can take as 24 into 24 by time you can take as 8 seconds you can take. So here 8 3 0 and here 2 500 times it is going, and here nearly will be getting as this is 36 into 10 power 3 watts will be getting. So but in terms of the horsepower they are asking, 1 horsepower equal to here will be taken 746 watts you are taking. When you are converting this watts into here horsepower, then you just take 36 into 10 power 3 into, then 1 watt equals here you can take as 1 by 746 horsepower you can take. You just convert by 746. So here this value here will be getting as nearly this is 48 horsepower will be getting. Let us see the next question. An elevator's motor produces 3000 watts power. The speed with which it can lift a 100 kg load they are asking. So here a motor is going to be giving the 3000 watts power. The speed with which it can lift the load they are asking. So here we just look at students. Here power is given. Power in terms of the velocity, we know here instantaneous power which will be equal to F into V you can take. So force is nothing but here it is going to be lifting the weight. So here it's nothing but here you can take as mg into V you can take. So velocity they are asking here V equal to here you can take as P by M into G you can take. So power here it is given as already 3000 watts is given. Mass here it is given as this is 1000 into G value you can take as 9.8 you can take. So here it is 3 times, here I will be getting as 3 by 9.8. Then velocity nearly will be getting as 0.306 meter per second I will be getting. This is the correct answer. Let us see the next question. The next question says a motor pump set lifts 300 kg of water per minute. Water it's going to be lifting 300 kg of water per minute from a well of the depth is given as 20 meters and delivered to a height of 20 meters. So here a motor pump you are taking students. So here one well is given, and here it's going to be lifting, it is at a depth of here 20 meters is given, and here it's going to be lifting the water and to certain height it's given. It's a motor pump we can take, and then its power they're asking. Power equals will be taken as the rate of doing work. Here it's going to be lifting the water, and here the height also is given, depth of the well is given, and here it is going to be lifting the water to a height of, again here it is 20 meters height is given. So together work done can be stored in the form of the potential energy you can take. Here mgh by T you are taking. So here P equal to mass it's given as 300 kilogram, and here it's a 9.8. Height it doesn't mean here you can take as total height you can take as, that is 20 plus 20 you can take. By time you can take as 1 minute is given, you have to convert into 60 seconds. So when you are simplifying this one, here we will be getting as nearly 1960 watts you are getting, and here which we can write it as in terms of kilowatts, in the sense 1.96 kilowatts you can write. So this is the correct answer. Let us see the next question. The next question says a man carries a load of 50 kg to a height of 40 meter in 25 seconds. If the power of the man is 1568 watts, the mass of the man they are asking. So here a man is carrying the load is 50 kg to a height of 40 meters in 25 seconds. So here you just look at students, power equals to, here you can write as the rate of doing work, and here he is carrying the load to a height is given. Height, if it is given, means here you be remembered work done can be stored in the form of the potential energy. Now here you can write as m into g into h by t you can write. Mass, in the sense here you can write as along with the persons, he is going to be carrying the weight also it's given, and here the mass of the man they are asking. Capital M represents, here you can write as mass of the man, plus here you can write as mass of the load you can take, into you can write as g into h you can take by t you can take. Along with the person's mass, here a load also is going to be carried out, so that we need to consider the both the masses. So here power already is given as 1568, which will be equal to mass of the man we don't know, plus mass of the load it's given as 50 kg into g you can take as 10. It is taken to a height of 40 meters by time you can take as 25 seconds you can take. So here you will be getting as nearly this is when you are simplifying this one, here you will be getting as mass of the man nearly will be getting as 50 kg you will be getting. This is best you can take as 9.8 you can take, then we will be getting the correct answer. So it's going to be carrying the 50 kg mass will be getting. Let us see the next question. A man of mass is given as 60 kg. He is lifting a 15 kg mass to the top of the building up to a height of 10 meters in 5 minutes. His efficiency they are asking. So here efficiency formula, students, here you will be getting as power output by power input will be getting. Power output to the power input there, right? You will be getting. Power is nothing but here again you will be getting as output power, right? Input input you are giving something here, and output how much it is going to be delivering. So power can be stored up. Again here it will be power in the sense here work done by time we can take, and he is carrying the load. A 60 kg man lifts a 15 kg mass to the top. Here mass of the load is the output which is going to be delivering. So here into g into h by time you can take. This is an output power. Here input power in the sense along with the mass of the man, and this load also it's going to be delivering. So here you can take as mass of the load, plus here you can take as mass of the man into gh you can take, into gh by time you can take. Time you have to cancel here, gh you have to cancel, and even efficiency you can take as here output work to the input work also you can take when time you are going to be removing. It's nothing but here you can get it as mass of the load by, here we will be getting as mass of the load plus mass of the man you can take. So here that's efficiency, here we will be getting as 15 by 15 kg mass he is going to be delivering, and here this is 15 plus mass of the man is given as 60 is given. So here 15 by here 75 will be getting, it's 5 times, here 1 by 5 is nothing but 0.2 will be getting. Efficiency in terms of the percentage they are asking, so 0.2 into 100, which you can get it as 20% will be getting. So this is the correct answer. Let us see the next question. The next question says a truck of mass 30,000 kg moves up an inclined plane, it's given. A 30,000 mass, here it's going to be moving an inclined plane. Of slope is given as 1 in 100 is given. Students, here a slope 1 in 100 in the sense here you can take as 1 in the sense here you can take as opposite side, and 100 you can take as a 1 you can take as opposite side, and 100 you can take as hypotenuse side you can take. Now here so you are carrying the load, here it's given. A truck of mass 30,000 kg, it's going to be moving up with the speed is given as 30 km per hour is given, and here the power of the truck they are asking. Power, the formula will be getting as here it's a velocity is given. In terms of the velocity means here you can take as this is here when you are taking here g, when you are resolving this one here, this is mg cos theta will be getting, and here this side will be getting as mg sin theta will be getting, and velocity will be getting as along this direction will be getting power equals here will be getting as f bar dot v bar. So here f and v both will be acting in opposite direction, of course will be getting as negative. So here we are going to be calculating only its magnitude. Here you can take as f into v. F is nothing but here you can take as mg sin theta component you can take into you can take as v you can take into v you can take. So P equals here you can take as mass is given as 30,000 kg into G you can take as 10 into sin theta. Sin theta is nothing but here opposite side is 1 and here hypotenuse is given as 100 it's given. That you need to substitute into it's a 30 km per hour you have to convert. So 1 km per hour equals to 5 by 18 meter per second will be getting. Now you have to cancel this one. Here 6 5s and 6 3s will be getting, and here 100, this 10 and 10 here it will be gets cancelled. So here will be getting as this is 3000 into this is 5 5s are 25 by 3 will be getting, and here one time it goes. So nearly will be getting as 25,000 will be getting. Power equals to 25,000 watts will be getting, and here we can write in terms of the kilowatts is 25 kilowatts. This is the correct answer. Let us see the next question. The next question says an engine of mass 1 metric ton is ascending in an inclined plane at an angle is given as tan inverse of 1 by 2 with the horizontal. An engine mass is given and it's moving on an inclined plane of tan theta value is given as, so here you can take as tan theta which is given as 1 by 2, that's nothing but theta equals to here you can take as tan inverse of 1 by 2. So this is what they have given. So theta equals to you have to consider as here opposite side by adjacent side you can take, then obviously hypotenuse will be getting as side square plus side square root over 5 will be getting. Then here an engine of mass it's going to be moving. Here you can take an engine of mass, here it's going to be moving with the 1 metric ton is given. So now here you have to take 1 metric ton right, which will be equal to here you can take as 1000 kg. So be remember students, here 1 metric ton which will be equal to here you have to take as 1000 kg. So here it's making an angle theta with the horizontal with a speed of 36 km per hour you have to convert. So it is 5 by 18 meter per second, 18 2s are here will be getting as 10 meter per second will be getting. If the coefficient of friction of the surface is 1 by root 3, so here it's a rough surface is given, its a coefficient of friction is given as 1 by root 3 it's given. Then the power they are asking. So here you just look at students, here when the engine is going to be moving this side, here there are two forces is going to be acting. Here this is the weight G it's going to be acting. When you are resolving this one, here this is theta, this component will be mg cos theta, and here this will be the mg sin theta will be getting. And when the engine is going to be moving this side along tangential direction, here a frictional force also it's going to be acting. So frictional force formula F equal to will be getting as mu into n. N is nothing but here it's a this is a normal reaction it's going to be acting. N can be balanced by the weight component is mg cos theta you can take. So now here they're asking the power they're asking P equals to here you can take as F into V you can take. What are the forces in the sense? So one is the gravitational force is going to be acting, and second one is the frictional force. Both will be acting opposite to the motion of the body. So here F bar dot V bar in the sense here you can take as F cos 180. Cos 180 is nothing but here will be getting as minus F into V will be getting. But here both will be acting in opposite direction. Here mg sin theta and as well as these two. So here you have to take as minus into minus plus you have to take. So P equal to, here you just calculate the net force value. One component is mg sine theta, plus here we will be getting as next force is the frictional force is going to be acting, that's nothing but mu mg into cos theta into you can take as V you can take. Now here you have to substitute the value, students. Here P equal to, suppose here mg when you are taking common, here this is sine theta. Sine theta from the triangle you will be getting as, it's an opposite side by here hypotenuse will be root 5 will be getting, and whereas cos theta value will be getting as 2 by root 5 will be getting. So here sine theta value you have to substitute 1 by root 5 plus mu value already is given as 1 by root 3 into here cos theta value, here it is 2 by root 5 you can take, into velocity you will be getting as here 10 meter per second you can take. So when you are simplifying mass you have to substitute here this is already is given as 1000 kg, right? Here 1000 kg also when you are substituting 10 power 3 into here 10, and here you can take as 1 by root 5 also if you are taking common, and here it is 1 plus this is 2 by root 3 and to 10 will be getting. So when you are simplifying these values, nearly will be getting as here in terms of the power in watts they are asking, this is nearly will be getting as 94,400 will be getting. So this is 94,400 watts is the correct answer. Now let us see the next question. A pump of 200 watts power is lifting 2 kg water per second. So here a mass which is delivering per time is given as, here it is 2 kg per second it's given per second. So from an average depth of 10 meters is given, and here the velocity with which the water comes out of the pump they are asking. So here initially input power is given as 200 watts. With the what velocity the water is going to be coming outside they are asking. So here you are pumping the water, students, from the depth is given. So here power equals to, here you can write as work done by time, and here be remember here work done can be stored in this case here both in potential energy and as well as kinetic energy. So that is half mv square by T will be getting. So right here this work done you are lifting the water from a depth. So here that work done can be stored in the form of both the potential energy, and it has come out with a velocity of some is given, and this is half mv square by T you can take. Here in both the cases m by T if I am taking common, P equals to, here we will be getting as G into H plus, here it is V square by 2 will be getting. Now power is given already here 200 watts is given. So this is a mass delivered per second is given as 2 kg per second. Here 1 we can take into GH. So it's 9.8 into, so depth is given as here 10 meters is given, 10 plus here you can take as V square by 2 you can take. So just cancel this one here. This is 2 into 100 will be getting. So 9.8 into 10 will be 98 will be getting. 100 minus this is 98 which will be equal to V square by 2 you can take, which is nothing but V square by 2 which will be equal to 2, V square equal to 4 will be getting, then velocity which will be equal to 2 meter per second will be getting. Let us see the next question. The next question says a machine gun fires 360 bullets per minute, and here each bullet moves with a speed of here 600 meter per second. If the power of the gun is 5.4 kilowatts, the mass of each bullet they are asking. So here you are delivering the bullet by using the machine gun. Here power equals to, here will be getting as the rate of doing work, students. Here work done can be stored in the form of the kinetic energy you can take, here that is half mv square by T or T. But you are delivering the n bullets. So here n bullets each will be having kinetic energy you can take as half mv square you can take. So here you just simplify this one, n number of the bullets in the sense P equal to here 360 bullets you are delivering per minute. It's given per minute. Minutes you have to convert into seconds. Into here half into mass, it's given as the mass of each bullet. We need to calculate here v square. So v in this is 600 meter per second it's given. Here you have to take a 600 into 600 you can take. Then power also already it's given as 5.4 kilowatts is given. So you just convert kilowatts into watts. So here we'll be getting as, it's getting as 5400 watts will be getting, which will be equivalent to here this is 66 times it goes, and here you'll be getting as again 3 times, and here 3 into m into here you can take as 6 6 is 36 into you can take as 10 power 4. Here 2 zeros gets cancelled, and here 10 power 2 3 18 times. So m equals here will be getting as 18 by this is 36 into here you can get as 10 power 2. So here 18 2 0 will be getting, and here this is 1 by 2. Here I will be getting as 0.5 will be getting. This is 0.5 into 10 power minus 2 kilograms will be getting. So here you have to convert into the grams in the sense here m equal to here will be getting as 0.5 into 10 power minus 2 into 1 kilogram equals 1000 grams you can take. Here it is 10 power 1. 0.5 into 1 will be 5 grams will be getting. So 5 gram is the correct answer. Let us see the next question. The next question says a motor is used to lift the water from a well of depth is given as 10 meter, and to fill a water tank of volume is given as 30 meter cube in 10 minutes is given. The tank is at a height of 20 meter above the ground. If 20% of the energy is wasted, the power of the motor they are asking. So here you just look at the students. Here efficiency formula will be getting as the power output by here will be getting as power input will be writing. Already here 20% of the energy is wasted in the sense, then the efficiency of the engine you can take as 80% alone. The percentage efficiency here 80% is given. Then you can take as 80 by 100. So here you are lifting the water from the depth is given. So work done can be stored. Right, work done can be stored in the form of the potential energy you can take. Output power in the sense here you can take as work done can be stored in the form of potential energy by time you can take. This is an output power to the power of the motor they are asking. This is the input power which is going to be giving to give the output. This is an mgh by t. By input power I am taking as P I am just taking. Now here you can take as this is mass, we don't know here mass, here it's given as volume into density you can take into G into H by here you can take as P into T you can take. This P it will come to the denominator. Mass is not given, and here density equals here you can take as mass by its volume. So volume equals to here mass is nothing but volume into density you can take into GH by P into T. Now here you just substitute the values here students. Here this is 110 gets cancelled. Here we will be getting, and this is like 0.8 will be getting, and here P which will be equal to volume here it's given as 30 meter cube. You are lifting the water density will be 10 power 3 kg per meter cube. It's 9.8 from the depth of 10 meters is given by, so time value here it is given as 10 minutes is given. Here you can take as 10 into here you can take as this is 60 seconds you have to take, and this is 0.8 will be getting, and this is 0.8 you have to bring into the denominator. So power, this values and all you are calculating in the sense nearly this value will be getting as 18.75 kilowatts will be getting. So this is the correct answer. Let us see the next question. A train of mass is given as 800 metric tons is moving with the velocity is given as 72 km per hour. So mass it is given as here 800 metric ton it's given. 800 metric ton in the sense here you can take as 10 power 3 kg. 1 metric ton equals to, here you can take as 1 metric ton which will be equal to 1000 kg, you can take 10 power 3 kg. So and here it's moving the speed of, here it's going to 72 km per hour, you have to convert 5 by 18 meter per second, 18 4s, 4 5s will be getting as 20 meter per second. So here the resistive force acting on the train is given as 10 Newton per metric ton is given. The power of the engine they are asking. So power, which is the formula you will be getting as here this is F into V, you can take here instantaneous power F bar dot V bar you are taking here, they will be moving along the same direction as here you can take as F into V you can take. So here it is given as 800 metric ton is moving, it's given. So how much force is acting in the sense per metric ton is 10 newtons. So 800 metric tons in the sense here the force value will be getting as 800 into each metric ton, it's going to be giving the 10 newtons resistive force is going to be giving. Right here, and this is a resistive force into velocity contact, right? Into velocity. Velocity is nothing but here we will be getting as 20 meter per second we will be getting, and here you will be getting a, this is 8 into 20 you will be getting as here 160 you will be getting 160 into this is 1000 you have to take. So here we will be getting as power value you will be getting as 160 kilowatts you are getting. Let us see the next question. The next question says a man of mass is given as 80 kg and here he is carrying the load of 20 kg and he walks up on a staircase in 20 seconds. If the number of steps is given as 40 and width and height is given as 20 centimeter and 15 centimeter respectively, the efficiency of the man they are asking. So efficiency general formula will be getting as power output to the power input will be getting. This is the basic formula. And here a man of mass carrying the load. Man along with the load he is going to be moving in a staircase. So here you just look at. This is the staircase you just imagine. So here you can get power is nothing but here will be getting as generally work done by time will be getting. So work done here, right, this is all about the gravitational force we are taking here. So here person when he is moving along the width, or else here he is going to, along with the person he is carrying the load. So here together here is going to be reaching like here, and here is attaining certain height you can take. And power equals here work done by time when you are taking here you can take which is useful work which is he is doing, or else output work by input work you can take even. And here it's a work done by time when you are taking here mass of the man which is carrying the load, right? Mass of the load into you can take as G into H by time you can take by input power in the sense here along with the man here a load also it's going to be moving into GH you can take by T you can take. So power equals output power I am just taking as here output he is delivering only the load. So load mass into G into H by T by input power in the sense along with the man here load also it's moving. So here you have to take GH by T, GH by T you just cancel, then efficiency which will be equal to mass of the load by mass of the man plus here you can take as mass of the load, which is nothing but here mass of the load it's given as 20 kg by here mass of the man it is given as 80 kg plus 20, which is nothing but 20 by 100 you can take 25. So the efficiency value will be getting as 0.2 will be getting. So in terms of percentage in the sense here you can take as 20% you can take 0.2 into 100, that is 20% you will be getting. Let us see the next question. The next question says a motor is pumping water with a velocity of 20 meter per second from the pump of area of cross section is given as 10 centimeter square. It's an average power they're asking. So here motor pump is going to be pumping the water with the velocity is given. So power equals to when you are taking rate of doing work, and this work done can be stored right in the kinetic energy. Here you can take as gain in kinetic energy by time you can take, which is nothing but here you can take as half mv square by t you can take. So here mass is not given. Here instead of mass you have to take as volume into density. Pump area is given. So here you can take as volume into density into here this is capital V you have to take, and the velocity square you can take by time you can take. So which is nothing but P equals to, which will be equal to volume again you can take as this is half into area into here it's, so you can take as length you can take, length by time into here you can take as density into here you can take as V square you can take, which is nothing but here you can take as here half into, so here this is a distance by time is distance covered by the water in a given time will be called as velocity. So here A into rho into here you can take as V square will be getting velocity, and here this represents one more velocity will be getting, V into V will be getting as V cube will be getting. So this is a formula will be getting to the power, average power, P equal to half into A into rho into V cube is the velocity will be getting. Now just simplify these values. Here P equals to half into area of cross section is given as 10 centimeter square. This is 10 into centimeter square you have to convert into meter, 10 power minus 4 meter square into you are delivering the water density will be getting as 10 power 3 kg per meter cube, and here its velocity will be given as 20 meter per second. So 20 whole cube we have taken this as 2 to the 4, 2 to the 8 into here you can take as 10 power 3 you can take. Here this is 10 into 10 power minus 3 will be getting 1, 10 power minus 3 plus 3 gets cancelled, and here 2 4 times you will be getting. So here you can take as power value will be 4 into 10 power 3, which is nothing but they will be getting as 4 kilowatts you can take. The next question says human heart pumps 70 cc of blood at each beat against the pressure of 125 millimeter of Hg. So pressure due to the blood is given, right? P equal to pressure due to the fluid is formula will be P equal to rho into G into H, G into H you can take. This is the pressure due to the flood is given. Rho is nothing but here density of the blood you can take. Yes, here you can take as rho into G into H. Here it's going to be pumping 70 cc, right? Here its volume is given as 70 cubic centimeter. Is 1 cubic centimeter equal to here you can take as 10 power minus 2 70 cc. Here you have to convert, which is cubic centimeter you have to convert 10 power minus 2 whole cube. 1 centimeter I am just converting into 10 power minus 2 meter cube I am just taking. So here you can take as volume it will be 70 into 10 power minus 6 meter cube will be getting. So now you just 72 per minute they are given the pulse frequency, the power of the heart they are asking. Now power equals to the formula, the rate of doing work. Work done is again here you can take as in terms of the velocity and force in the sense. Here you can take as work done equals force into displacement by time, which is nothing but you can take as force into here you can take as velocity you can take. Force into here you can take as velocity you can take, and here now you have to substitute here pressure equals the formula force by area. Instead of force you can take as pressure into area you can take. This is the pressure into here you can take as area you can take, into here you can take as velocity you can take. Even wait students, here you will be getting as here this is in terms of volume you are taking this is here you can get it as power equals to here will be getting as the rate of doing work, which will be equal to here work done equals to even you can take as dW equals to here you can take as pressure into volume you can take P into dV. So here you can take as P into here you can take as V is nothing but here you can take as volume you can take by time you can take. So dW equals here in terms of the pressure and volume, the formula will be pressure power formula P into dV by T you can take or V by T you can take. So pressure doesn't mean here will be getting as force by area, right? So P in the sense here you can take as this is H into rho into G you can take into volume by here 1 by T. 1 by T is nothing but here it's getting as number of beats per minute is given, frequency is given. So here you can take as number of beats you can take as N you can take by time you can take. This is the total power formula students. Here you can take P equals to here you can take as N in the sense here number of beats heard per second, right? Here each minute it's going to be pumping 72 per minute, it's given pulse frequency. So number of beats heard per second in the sense here you can take as 72 by 60 you can take. This is a H in the sense here you can take as 125 millimeter is given, 125 millimeter in the sense 10 power minus 3 into here you can take as mercury is given, right? Density of the mercury value, density of the mercury here you can take as 13.6 gram per cc or 13,600 kilogram per meter cubic and take. Here I am just taking as 13,600 is the density of the mercury in SI system into G value you can take as 10 you can take. Volume you are pumping as 70. So here I just converted as 70 into 10 power minus 6. After all, when you are calculating all these calculations, here will be getting as nearly the value will be getting as 1.428 watts will be getting. So 1.4 watts is the correct answer. So here power equals to the rate of doing work you can take. Work done in terms of pressure and volume will be dW equals to PV. The heat topic will be getting that you need to substitute. So P equal to H rho G you have to substitute into velocity you can take. Let us see the next question. A body of mass 2 kg starts from the rest and moves with the uniform acceleration. If it is acquiring the velocity of 20 meter per second in 4 seconds, the power consumed is 2 seconds they are asking. So here power is nothing but here you can take as work done by time, the rate of doing work. So it's going to be accelerating from the rest with a uniform acceleration it's given. So work done is nothing but change in kinetic energy you can take according to the work energy theorem, half mv square minus half mu square by time you can take. So initially it starts from the rest is given. So here initial kinetic energy will be 0. So P equals here you can get it as half mv square by T you can take. Half into mass it is given as 2 kg, velocity will be getting as 20. So 20 whole square is nothing but here you can take as 400 you can take by time. Time is given as 4 seconds. So here 2 gets cancelled, here 400 times it goes. So power equals here will be getting as 100 watts will be getting. Let us see the next question. The next question says here, a pumping machine pumps water at a rate of 60 cc per minute is given at a pressure of 1.5 atmosphere. So the power delivered by the machine. So power which will be equal to here you can take as the rate of doing work in terms of pressure and volume in the sense here dW equals to here work done equals to in thermodynamics topic will be getting in terms of the pressure and volume in the sense dW equals here will be taken as P into dV. So here you can take as P into dV by T you can take. And this is the volume and time, this is the pressure, and this is the power. So here power equals to, in terms of pressure and volume, will be P into dV by dV T you can take. So this is volume, students. Here don't get confused, not the velocity. Here power, which will be equal to, so this pressure is given as 1.5 atmosphere is given. It's a 1.5 into 1 atmosphere equals to 10 power 5 Pascal into here volume you are pumping at 16 cc cubic centimeter. So 1 cubic centimeter, which will be equal to, or 1 centimeter cube, which will be equal to, here you can just 10 power minus 6 meter cube. So volume here it's given as 60 cc, you have to convert into 10 power minus 6 meter cube by here per minute they are asking. Here per minute, in the sense you have to convert into 60 seconds. So here you have to cancel, this is a 10 power 5 and here it becomes 10 power minus 1, and here 1.5 into 10 power minus 1, so in nearly you will be getting a 0.15, will be getting 0.15 watts. Let us see the next question. The next question says, a block of mass m is moving with a constant acceleration a on a frictional plane if the coefficient of friction between the block and as well as ground is given as mu. So block it's given, and here it's going to be moving with the uniform constant acceleration on a frictional plane it's given. Coefficient of friction is given as mu is given. The power delivered by the external agent after a time t from the beginning is equal to. So here it's a moving with the constant acceleration is given. Here you can take it's moving with certain acceleration, in the sense here the external force is going to be acting along this direction, and here it's a frictional force is going to be acting opposite to the motion of the body you can take. Then net force, when you are taking here this is, if the coefficient of friction between the block and ground is mu, the power delivered by the external agent, this is the external force will be taking, and here you can get it as net force, which will be equal to, here you can take as this is an external force, external agent you can take, external agent is doing some work, minus here you can take as frictional force you can take. So here you can take that this is power by this is external agent, this is the power force due to the external agent you can take, and F net causes an acceleration, this is the force due to the by the external agent minus F you can take. So force due to the external agent is nothing but, here you can take as MA plus F you can take. Now here you can take this is the force value you will be getting, but they are asking what here, the power delivered by the external agent. Power formula will be getting as force by the external agent into velocity you can take. Here Fe already we got it as Ma plus F into you can take as velocity you can take as V you can take. P equals to Ma plus F, in the sense here you can take as frictional force, which will be equal to, this is a normal reaction, and here is going to be balancing the weight of the body, mg you can take. So mu into n, n is nothing but here you can take as mg you can take, and here m is blocking with a constant acceleration is given. So v equal to here this is f equal to mu into n you can take. So velocity v equal to, here the formula will be u plus at. Here initial velocity will be 0, will be getting plus at you can take. That value you have to substitute here. This is a into t will be getting. Now just look at the answers here. What you can write here, this is m you are taking common. So m, if I am taking common here, this is a plus this is mu g into you will be getting as a into t will be getting. So this is the correct answer. Let us see the next question. The next question says, an 8 kg block accelerates uniformly from the rest to a velocity 4 meter per second in 40 seconds is given. The instantaneous power at the end of the 8 seconds they are asking. So velocity first you need to calculate at the end of the 8 seconds, students. velocity at the end of the 8 seconds, in the sense v equals to, here you can get it as u plus at from the rest, in the sense 0 plus with what acceleration it's moving. So first we need to calculate the acceleration also. So here u plus, here this is 4 seconds is given, here 4 meter per second, a into t value, t is given as 8 seconds is given. So a 8 kg block accelerates uniformly from the rest with a velocity of 4 meter per second in 40 seconds, students. This is about 40 seconds you can take. So here we will be getting as 4 or 10 times it goes. It's moving with the uniform acceleration for 40 seconds is given. So here we just calculate the acceleration value. A equals to, here we will be getting as with this 1 by 10, which is nothing but we will be getting as 0.1 meter per second square you are getting. Now here you just calculate the power at the end of the 8 seconds they are asking. At the end of the 8th second, in the sense here at 8th second you can take velocity. So first you just calculate the velocity at the end of the 8 seconds. V equals u plus at, and initial velocity will be 0. Here acceleration we got it as 0.1, and the time is given as at the 8th second. So here we will be getting a 0.8 meter per second we will be getting. So power, instantaneous power formula will be getting as F into V you can take, and here force causes an acceleration m into a into you can take as V, which is nothing but mass is given as 8 kg into acceleration is 0.1 meter per second square into velocity will be getting as 0.8 will be getting. So if you are substituting 8 8 are 64, and this is here nearly will be getting as power value will be 0.64 watts will be getting. Let us see the next question. A projectile is projected initially with a velocity is given as 20 meter per second and at an angle as 30 degrees. So a projectile you are projecting with a velocity is given as 20 meter per second, and here which is making an angle 30 degrees from the horizontal. It's making as 30 degrees from the horizontal. Find the average power up to a time when it will hit the ground. Here the moment here we are projecting is going to be hitting the ground like this, and here in projectile motion, right, we learnt already with 20 meter per second if you are projecting. Here the with what velocity is reaching is 20 meter per second velocity alone. So here you can get it as find the average power up to the time when it will hit the ground. Average power is nothing but, here you just look at power equals to, here you will be getting as work done by time. Work done equals to force into, you will be getting as displacement. So force into displacement, in the sense here we will be getting as this is the gravitational force into displacement, right? Vertical displacement value, here it's not going to be getting the horizontal displacement alone, not the vertical displacement. So gravitational force, here it's going to be acting downwards, mg, and here vertical displacement value will be 0. So here mg into, here you can take as displacement will be 0 into by time you can take. Here we will be getting as power value will be getting as 0 will be getting. That doesn't mean here work done by the gravitational force, here it will be 0 will be getting, right? Or else you can take as even in another way also you can do this this kind of problems. Power equals, here will be getting as work done by time. Work done is nothing but change in kinetic energy, you can take half mv square minus half mv square by time. So there is no change in kinetic energy, velocity will be same, will be getting here. This is 0 by t, which will be equal to 0 you can take.